everyone, welcome to REE's tutorial. So this is the first part of our registered electrical engineer reviewers. So for theory. So let's start. We have question number one. The power consumed in a circuit element will be least when the phase difference between the current and the voltage is A 180 degrees, B 90 degrees, C 60 degrees, D 0 degrees. So the answer is 90 degrees. So that is the phase difference between the current and the voltage. The phase difference between the voltage and the current wave through a circuit element is, is given as 30 degrees. The essential condition is that A. Both waves must have same frequency. B. Both waves must have identical peak waves. C. Both waves must have zero value at the same time. D. None of the above. So what's your answer? For question number two. So the answer will be both waves must have the same frequency. So that is the most essential condition if we are given in 30 degrees difference between the voltage and the current. So let's proceed. The best place to install a capacitor is blank. A. Very near to inductive load. B. Across the terminals of the inductive load. C. Far away from the inductive load. D. Anywhere. So the answer will be letter B, across the terminals of the inductive load, since the capacitor has the ability to correct those lagging inductive loads, right? If you remember. So number four, pure inductive circuit. A consumes some power on average. B does not take power at all from a line. C takes power from a line during some part of the cycle and then returns back to its during other part of the cycle. D none of the above. So the pure inductive circuit it, takes power from the line during some part of the cycle and then returns back during the other part of the cycle. So this is called the back EMF. So that's the one of the character of the inductive circuit. So that's why you have high current when you have a inductive load because we have a back EMF. Number five, the inductance affects the direct current flow. A. Only at a time of turning off. B. Only at a time of turning on. C. At the time of turning on and off. D. At all time of operation. So what's the answer of question number five? B. Only at the time of turning on. So that is the inductance affects the direct current flow. Number six, power factor of the system is keep high. A. To reduce line losses. To maximize the utilization of the capacities of generators, lines, and transformer. To reduce voltage regulation of the line. Due to all above reason. So the answer is due to all above reason. Diba? Diba? If you have a high power factor, so you will reduce the line losses. If you have, for example, zero point 0.9 power factor, so it reduces line losses to maximize the utilization of the capacity of the generator, lines, and transformer, and also to reduce the voltage regulation of the line. So we'll proceed to question number seven. In a loss-free RLC circuit, the transient current is A. Oscillating, B. Square wave, C. Sinusoidal, D. Non-oscillating. So the answer for number 7 is sinusoidal. So it is a loss free of the RLC circuit. Number 8, the double energy transient occur in the A. Purely inductive circuit, B. RL circuit, C. RC circuit, D. RLC circuit. So the answer for number 8 is RLC circuit. 9. In the case of any unsymmetrical alternating current, the average value must always be taken over A. Unsymmetrical part of the waveform, B. the quarter cycle, C. the half cycle, D. the whole cycle. So what's your answer? So the answer for number 9 will be the whole cycle, letter D. Pure inductive circuit takes power from the AC line when A applied voltage decreases but current increases, B applied voltage increases but current decreases, C both applied voltage and current increase, D both applied voltage and current decrease. So your answer for number 10 is what? So the answer for number 10 is A. Applied voltage decreases but current increases. 11. In RLC circuit, A power is consumed in resistance and is equal to IR. B. Exchange of power takes place between inductor and supply line. C. Exchange of power takes place between capacitor and supply line. D. Exchange of power does not take place between resistance and a supply line. E. All above are correct. So what's the answer for number 11? So in a circuit for the RLC circuit is all above are correct. Number 12. The time constant of a series RC circuit is given by A. R over C, B. RC squared, D. C. RC, D. R squared C. So the answer of the time constant of a series RC circuit is RC. So let's proceed to number 13. The safest value of the current the human body can carry for more than 3 seconds is what? A. 4 milliamps, B. 9 milliamps, C. 15 milliamps, D. 25 milliamps. So the answer for number 13 is 9 milliamps. So the apparent power drawn by the EC circuit is 10 kVA and the active power is 8 kilowatts. The reactive power in the circuit is A 4 kVAR, B 6 kVAR, C 8 kVAR, D 16 kVAR. So what's the apparent power? So by using the Pythagorean theorem, so we have the square root of 10 kVA squared minus 8 kilowatt squared is equal to 6 kVAR, 6 kVAR, which is the reactive power. Number 15, a phasor is a line in which represent the magnitude and the phase of the alternating quantity. B. A line representing the magnitude and the direction of the alternating quantity. C, a colored tag or bond for distinction between different phases of the three-phase supply. D, an instrument used for measuring phases of unbalanced three-phase load. So a phasor is what? A line which represents the magnitude and phase of alternating quantity. 6. A wire-wound resistor are unsuitable for the use of high frequency because they A. Create more electrical noise, B. Are likely to melt under excessive EG current heat, C. Consume more power, D. Exhibit unwanted inductive and capacitive effects. So the answer for number 16 is exhibit unwanted inductive and capacitive effects. So that is for wire wound resistors. They are not suitable for the high frequency. So number 17, a pure capacitor connects from the AC voltage consumed 50 watts. This is due to a capacitive reactance in ohms, B, current flowing in the capacitor, C, the size of the capacitor being quite big, D, the statement is incorrect. So the answer for number 17 is the statement is incorrect. So it is not true. So if you have a pure capacitor and it is connected to the AC voltage, it says 50 watt. It says it consumes 50 watts. No, it depends of your circuit or equipment that is being connected. So this statement is incorrect. Number 18, the two waves of the same frequency have opposite phase when the phase angle between them is A 360 degrees, B 180 degrees, C 90 degrees, D 0 degrees. So the answer is 180 degrees. So the two waves of the same frequency have opposite phase when the phase angle between them is 180 degrees Celsius. No, 180 degrees. So the peak value, so let's proceed to number 19. The peak value of the sine wave is 200 volts. Its average value is A 127.4 volts, B 141.4 volts, C 282.8 volts, D 200 volts. So we have E 127.4 volts. And then number 20, in a purely inductive circuit, A, uh, A actual power is 0, B reactive power is 0, C apparent power is 0, D none of above is 0. So if you have a purely inductive circuit, you have A actual power is equivalent to 0. Since the current and the voltage are in 90 degrees out of phase from each other, like in the pure inductive circuit, the total power of the circuit would be zero as follows. This shows that in case of the pure inductive circuit, the total power of the circuit would have a zero as cosine 90 degrees is equal to zero. So that is why the purely inductive circuit is have a actual power of 0. So thank you for listening. That's all for today. Bye.